Good evening to one and all. My name is Venkatesh. Today I am going to explain about command lines used in large number program using 8086. Here we can see mount C used to mount the working directory from which DOS box was started. Mount C a specific folder from your hard drive. To change the directory from Z to C we use C, and here we can see that editing al.asm. ASM means automatic storage management. Now my friend Prashant will continue.
Hello, my name is Prashant. I am 19MIC0054. I am going to explain the code part. In this code, first two lines are installing the data segment so that SI is initialized as 3000, that is as stores in this register. Then DI, that has result address, it is 3500. Then we go to CI, the value which CI is pointing to, that is 4. Then CH is initialized as 00. Then we increment SI by 1. Then we load value from offset SI to registered AL. Decrease value of registered CL by 1. Then we increment SI, increasing the value of SI by 1. Then we compare AL, compare value of registered AL and SI. Then J and C jump to address bit if carry not generated. Move AL, transfer data at offset SI to registered AL. Increase value of SI by 1. After this, we increase if else statement. We create if else statement. If the value AL is greater than the value SI pointing to 1, all AL will take the value, that value, or it will keep the existing value so that AL will have bigger value. If carry flag is 0, then else part is executed, and if carry flag is 1, if part will be executed. Now our loop decrements CH value automatically. Then and the loop runs until it's 0, and at the end AL has the greatest value which has more to DI which has the result, and then process start, alt stop, end. Then next part will be explained by Venkatesh.
Now we are going to MASM file. It is an 86 assembler that uses Intel syntax for MS DOS. And now we are here we are going to see 0 warning errors and 0 severe errors. Now we use link command to combine assembled .obj files into executable, and debug command combines assembled .exe files into executable, and that is debugged. Now my friend Arun will continue.
I myself Arun Kiran. My register number is 19MIC0036. Now I am going to explain about the initial execution of the code. The first instruction is move ds, AX. We are loading the value of AX into the ds. ds is nothing but data segment points to data where data is stored. And the next instruction is move SI, 3000. SI is the source index register. It is consists of a 16 bits. It is used in pointer addressing of data and a source in something related to operations. The initial value of SI will be stored of 3000 hexadecimal value. And the next instruction, here we can see that the SI value is changed to 3000. And the next instruction is move DI, 3500. DI is the destination index register. It is also a 16 bits register. It will initialize out of final destination index as 3500 value. Here we can see that the DI value is changed to 3500. Now we will enter the input values. First one is 4 and second one is 5, 36, 23 and 12. Now we will use the display function and display the input values, whether the value is stored or not. Here in the first step, in 3000 value, 4, 5, 36, 23 and 12, the values are stored successfully. And the next instruction is we are entering another value and we are changing the 1e value to 0, 0. Here we will see that the value is changed or not.
Same here.
Here we can say that the value is changed to 0, 0.
Itiki.
And here we have displayed the total information of the input. On the next instruction, now my friend Srikar will explain about the other execution of the code.
Hello, my registration number is 19MIC0007 and my name is GVP Srikar Gupta. Now I am going to explain you about the another half part of the execution of the code. Now first I am giving the T instruction. Here we can see that the CH is 0 and here the CX value is 0004. First
Ma ekku
and
chey.
now I am giving another
Ma.
instruction T, and here we can see that the left part of the CX becomes 00 and 04.
Ma ekku chey.
Here the increment of instruction is given,
Mana takkoyindi.
and now again I am giving the T instruction. Here we can see that the data segment right side of the screen, we can see that the DS is initialized to 3001 to 005. This DS is called data segment register, and the data segment register information is stored to AL. Now I am again executing the instruction T. Here we can see the right part of the X becomes 05 because this 05 is initialized by the AL register. Now I am again executing the instruction T. Here increment part is done and the CX is also becomes 0003. This CX is executed up to the CX becomes 0000. Now I am again executing the instruction T. Here we can see that the data segment register incremented to 3002 and it is initialized with the value 36. Here this 36 is compared with the 05 value, and now I am again executing the instruction T. Here we can see that the JNB function is there. This JNB function is used to jump the values, and here we can see the value, and here we can see that the data segment register become 3002 and 36 because because here carry is 1. If the carry is 0 means the instruction is left. If here the carry is 1, that's why again it is giving the 36 value, and this 36 value is moved to AL register. Now I am again executing the instruction T. Here we can see the 36 value is initialized to AX register, and now again executing the instruction key. Here loop will come. This loop will be helpful to execute the instruction, and it is also helpful to reduce and also helpful to automatically decrease the CX register value up to 0000. Now I am executing the instruction T. Here we can see that the value of the data segment register is 300, incremented to 3003, and its value is 23. Now I am again executing the instruction T. Here we can see the JNB instruction. Now I am again executing the instruction T. Here increment is done. Now I am again executing the instruction T. Here loop will come. Again executing the instruction T. Here the value doesn't change to 23 because here it compares the 23 value with the before one, and here because of the less, because 23 is the smallest one, so it is not getting initialized with the 23 in the H register. And here also we can see that the data segment register is incremented to 3004 and the value is 12. Now I am again executing the instruction T. Here we can see the JNB instruction. Now I am again executing the instruction T. Here we can see the increment of the SA will be done. Now I am again executing the instruction T. Here loop will come. As I said, this loop will helpful to automatically decrease the CX up to 0000. Now I am again executing the instruction T. Here we can see that the data segment register with the 3500 having 00 because we changed the 74 value of 74 value in the data segment, 74 value to 00, and here the AL code is AL part is moved to DI part, and again now we can display the 3501, and now here we can see the 00, and again executing the T instruction. This will halt the code, that means end of the code. Now I am again seeing the 3500 register. Here we can see the number as 36. This is the largest value that I have printed in, that I have initialized there in the above part of the code. Now I am quitting the code. Thank you.